All right, hello and welcome back for part 2 of solving literal equations. In the two examples we take a look at here, there's going to be something a little different going on with the variable we're trying to solve for. And I'm going to need to take a look at that and see what we can do. So if I take a look here, I notice that I'm trying to solve for t. And it says 6t plus dt divided by x plus 5 equals y. So what's a little tricky here is that the t is in two different locations, right? T is both multiplied by 6, it's also multiplied by d before they're added together. And I'm not sure exactly how to deal with that for right now, but we'll come back to that. I do know that divided by x plus 5 is the last thing occurring. So I'm going to start with solving by getting rid of that x plus 5. Since they divided by x plus 5, we are going to multiply both sides by x plus 5. So I'm going to come over here and do x plus 5. Make sure that both sides get that. My x plus 5s are going to cancel. And what comes down on the left is going to be 6t plus dt equals, over here I could distribute the y through, but I'm not going to. I'm just going to bring it down as x plus 5, because my goal is to get t by itself. I really don't care too much about what format this is and over here. Now, to get t by itself, we are going to be using distributive property. And we're going to be using distributive property in the other direction from what we're maybe used to. We're used to taking something like this, y, and distributing it to both. That's certainly distributive property, but distributive property isn't directional. It also lets me recognize that I have a t on both of these two terms, and it allows me to take that t and bring it out. When I bring it out of parentheses, I'm going to take the t off of both and leave whatever's left over inside parentheses. So this term becomes a 6, plus this becomes just t. And if I take a look and distribute that t through, I would end up with 6t plus dt. So I know these two are equivalent to each other. And it gives the added benefit of having only one t, or at least t in only one location. Now I'm going to be able to solve for t. Since we're multiplying it by 6 plus d, I'm going to divide on both sides, and I'm going to divide by 6 plus d. Whoop, let me fix that 6 there. And I'm going to do that on both sides. So 6 plus d comes over here. We're going to cancel the 6 plus d. Those both cross out. And my t comes down. Over here, nothing really combines, nothing simplifies, so I just bring it down as is. Y times x plus 5 divided by 6 plus d. My pen is not working real great right now, but that's all right. That is what we are going to end with. I know it's solved. I know it's finished because t is by itself and everything else is over here. Hopefully that looks all right and makes a little bit of sense. All right, we're going to move on to the next special case. In this special case, we have a bunch of symbols that aren't typical letters we're used to seeing. These are Greek letters. This is epsilon, this is mu, this is psi, this is delta. The fact that they're not symbols we recognize really doesn't make it any more difficult. They're just variables. We just treat them like variables. So here, what's a little tricky is the mu that I'm trying to solve for is in the denominator, and I want to get rid of that. I've got a couple choices. I could multiply both sides by mu. If I multiply by mu over here, they would cancel. Or in this case, since I have a nice proportion set up, I have two fractions that are equal to each other, I can actually cross-multiply and deal with it that way. And that's what I'm going to choose to do here. So I'm going to multiply these two together, I'm going to multiply these two together, and we're going to bring down our results. So on the left, I'm going to do mu times psi, and then equals, on the other side, I have 4 epsilon times delta. Now I still want mu by itself. It's over here. Right now it's being multiplied by psi. I'm going to divide by psi on both sides. And that's all it's going to take. Because my psi's cancel, I end up with mu, and I get over here, nothing really simplifies again, so I end up with 4 epsilon delta, all divided by psi. And that is my finished result. I know I'm done because mu is by itself. It's a nice quick way to get mu out of the denominator. It's tempting to try to get rid of the 4 epsilon, but if I get rid of the 4 epsilon, then I still end up with 1 over mu, and I don't get mu by itself like I do when we cross-multiply. So that's going to be the tactic we want to take for this one. Hope that helps, hope that makes a little bit of sense, and I will see you guys next time.